Chemical engineering for dummies. Chemical engineers translate processes developed in the lab into practical applications for the commercial production of products and then work to maintain and improve those processes. They rely on the main foundations of engineering, which are math, physics, and chemistry. As a chemical engineer, you will be using analytical, problem-solving, and deductive reasoning skills to determine why a design does not work as planned and to troubleshoot to find a solution that does. Many of the processes within chemical engineering involve chemical reactions, and the field takes cues from chemists who are looking for new ways to create products and to investigate the mechanisms within chemical reactions. There are a wide range of industries that utilize chemical engineers, including pharmaceutical, energy, and information technology. Their roles, however, involve developing existing processes and creating new methods for altering materials. There are also other sectors and careers which utilize the skills developed in a chemical engineering degree, which include quality assurance, manufacturing, and consultancy. Popular chemical engineering jobs and sectors include chemical manufacture, cosmetics, food and drink, fertilizers, fuel and energy, healthcare, mining and minerals, oil and gas, and waste management.
Hi everyone. Now let's look at humidification process. So humidification process is a process where water vapor is transferred or added to air. Now we can look at this process based on two applications, which are air conditioners and also cooling towers. Now let's look at how these two applications work.
The basic idea behind any air conditioner is evaporation. When a liquid evaporates, it feels cool. If you put alcohol on your skin, you can feel the coolness as it evaporates. An air conditioner contains a liquid that evaporates, a lot like alcohol, but it evaporates at a lot lower temperature. The liquid evaporates inside the house. It evaporates inside a set of metal coils, and the liquid makes the coils extremely cold. A fan blows air across the coils, and that air is what cools your house down.
Cooling tower systems are widely used to provide cooling in industrial and commercial applications, including building HVAC, cold storage, and industrial cooling. The key components of a cooling system are the cooling tower, recirculating pump, and heat exchanger. Cooled water from the basin is pumped through a heat exchanger. The cooling water picks up heat, and its temperature increases. Warm water is distributed over the top of the tower, where air moves past the warm water, evaporating a portion of the water, cooling the remaining water. Repeating the loop.
First of all, what is an absorption? Absorption is a process used in the chemical industry to spread gases by washing or scrubbing a gas mixture. It will remove one or more two of constituent in the gas mixture, dissolve or absorb in a liquid. Gas absorption usually carried out in a vertical counter-current column, which the solvent is fed at the top and the gas mixture is fed from the bottom. Thus, it will need a vertical shape. Types of absorbers such as a packed column, flat tower, simple spray column, or a bubble column. Okay, the application of absorption is the first one is in a membrane gas absorption, which is used in industrial wastewater treatment and the treatment of flue gas and off-gas stream, and also used in acid gas removal in petrochemical industry. And the advantage is related to decreasing the installation of surface requirement through compact process designs. And one is in industrial absorption, such as in the chemical industry, plating industry, and food industry, and the major user of industrial absorption is a shipping industry.
Distillation. Have you heard about that? Distillation is the process of heating a liquid mixture to form vapor and then cooling the vapor to get a liquid. Distillation is used to purify a liquid by separating the components of a liquid mixture based on their boiling points. In chemical engineering, distillation process is widely used to refine crude oil into gasoline, naphtha, kerosene, diesel, heavy oil, and bitumen. Crude oil is heated up to a high temperature. The vapor pumped into the distillation column that has a heat gradient, hot in the bottom and going cooler to the top. Molecules with high boiling points begin to condense back into liquid and collected at the bottom of the column. The rest of the molecules start to rise up the column and condense at certain temperature. Each fraction has its important uses.
What is liquid-liquid extraction? Liquid-liquid extraction is the process of extracting a solid from a feed by using a solvent to produce an extract and raffinate. LLE is a method to separate compounds or metal complex based on their relative solubilities into different immiscible liquids. This is the reason why LLE is chosen. The simplest LLE involves three components, which are solute, carrier, and solvent. Here are the liquid-liquid extraction application. Making a tea is a good example of extraction. Water is placed in contact with tea bags and the tea is extracted from the tea leaf into the water. Washing is the process of selectively removing unwanted compounds from a mixture using a solvent. For a washing to be successful, the unwanted material must be more soluble in the solvent than in the mixture. Additionally, the solvent and mixture must be immiscible. The washing of dishes is a good example. Oily plates are placed in water. Oily dirt from the dishes are removed, leaving the plate clean by using liquid dishwasher. This works because the dirt is soluble in the water and plates are not.
So now I'm going to explain about what is solid-liquid extraction. It is a process where a substantial part of the solid does not dissolve and the soluble matter diffuses out through the solid during solid-liquid contact. There are 4 steps in solid-liquid extraction. The first step is to have a close contact between the solid feed with the solvent. It will then go through a separation of extract from the exhausted solid. The solvent and entrained solid remain from the extract will be separated, followed by purification. The final product will be in 3 states, which is dry, liquid, or paste extract. The solvent from the moist solid extract will be recovered. Are these processes applied in our daily life? What are the applications? It is widely used in food industry, such as extracting compounds from natural products like plant flowers, leaves, fruits, and roots. Another example is the extraction of sugar from sugar beet. In the first stage, the beets are washed and grated. It will then be plunged into an almost boiling water to dissolve the sugar contained in the beets, which will evaporate it until crystallization. And lastly, the extraction of oil from oil seeds. So the first step to extract olive oil is to first clean the olive. Then crush the olive into paste. The purpose of crushing is to tear the cells to facilitate the release of oil. Then mix the paste for about 20 to 45 minutes to allow the small oil droplets to combine into bigger ones. The paste can be heated or water added during the process to increase the yield. The next step consists of separating the oil from the rest of the olive components. This used to be done with presses, but now it's done with centrifugation.